Thank you for joining us for our fourth Forestry Speed Dating event focused on unlocking forest carbon markets. I am Andrea Arencibia from the European Forest Institute's Bioregions Facility, and I'm thrilled to moderate today's session. The Bioregions Facility's Forestry Speed Dating series is an engaging platform designed to spotlight innovative bioeconomy solutions. Our main goal is to facilitate knowledge transfer, encourage collaboration, and promote innovation in the forest-based sector. In case you missed our previous three events, or if you wish to revisit them, you can catch up on all the sessions, fact sheets, and slide decks on our website. So today's session is particularly special for us because we will hone in on two cutting-edge solutions from the Bioregions Open Innovation Challenge that was launched in December last year. Bioregions Open Innovation Challenges provide a framework to identify and support the development and scaling up of innovative solutions, which can be technologies, business ideas, or others to pressing challenges in forest management and on the forest bioeconomy. 3 innovative organizations were granted with 7,000 euros each to advance their projects. And at this event, you will meet Föra, Forest Technologies, with their AI-powered forecast tool that gauges forest carbon stock through conventional and LiDAR techniques. You will also meet ZertiCarbon, which provides landowners with in-depth insights into tree growth and carbon sequestration, harnessing state-of-the-art technologies to facilitate carbon offset acquisitions for both individuals and corporations. Before starting, we would also like to express our gratitude to our supporting regions, North Rhine-Westphalia, the Basque Country, and Catalonia. Their commitment to propelling a forest-driven bioeconomy is enabling us to organize these events. Also, a shout out to our incredible partners, the European Circular Bioeconomy Fund, the European State Forest Association, the Irish Bioeconomy Foundation, Bioeconomy Ventures, and Ubuntu. Kindly note that this session is also being recorded for your convenience. You can access the presentations and read the solutions fact sheets on the Bioregions Facility Forestry Speed Dating website following the conclusion of this event. So let's now dive right into the heart of forest carbon market innovation and let the Forestry Speed Dating begin.
Okay, so thank you all. And thanks the Bioregions Facility for this session. I'm Íñigo Lizarralde, I'm the CEO of Föra, and I'll be presenting today Forecast as a tool for estimate and monitor carbon. Just a few words about the company first. Föra is a forest technology and innovation company. We are basically focused on the assessment of forest resources, including carbon. And to do that, we use remote sensing, mainly LiDAR and satellite, and we develop artificial intelligence algorithms. We have quite a big expertise in LiDAR with more than 30 million hectares inventoried. And also satellite imagery with over 100,000 images and counting. We have this part of more scientific or academia part where we publish papers, but we also are very involved in competitive projects and IP registries and so on, with projects still now in 8 countries. Okay, but let's go to the point today. When we applied to this Bioregions Open Innovation Challenge for the carbon farming and climate smart forestry, we were thinking about helping solving this challenge through some reliable system to estimate and monitor carbon. We analyzed the bioregions, and I think that using forecast could help to switch part of the forest focus more focused on just wood of these bioregions. So switching part of it to carbon, and of course trying to engage stakeholders, something we are just doing today, hopefully. So when we started to think about it, and when we started to think that forecast could be a good option, we started seeing some challenges, problems, or future perspective of the forest carbon sector. One of the main things we saw is that the number of players in the market has suffered an exponential growth. There's a lot of buyers, sellers of carbon credits. And I think a good part of them lack reliability and transparency on how they calculate or how they estimate the carbon that it's in their credits. So I think that was creating reputational damage to the whole sector, and there have been quite interesting talks about it, how a lot of companies are doing really good damage to the ones that are doing properly and with this soundness that the market should have. So we saw that the solutions should be at least accurate and reliable. That means they should have scientific soundness. But not only that, because they should have biological sense. Don't forget we're talking about trees. So all the algorithms we create, they have to have this biological sense, not only robustness in a statistical way of seeing it, but just also having this biological sense. Of course, we need these algorithms to be updated, or the data updated, or the algorithms be able to update the data. So, of course, we're talking about some assets that's going to be for tens of years there. So we should be able to give updated information on the carbon stocks. Of course, the solution should also allow scalability, because we're not talking just about some small areas in some country. We're talking not only in Europe, we can use it everywhere. So that should be inside as a part of the system. And of course, if we are going to use it, and if we want people to use it, it should be user-friendly. You need a platform that it's easy for all users to use it with properly and with no problem. So with all of that, we thought that applying to this challenge, it was a good idea to do it using Forecast. So Forecast is the platform we've been developing the last years, and it's, among other things, what it offers is digital cartography, so digital terrain models and so on, but specifically forest inventory. We can do it from stand level to individual tree level. And this forest inventory includes several variables, forest variables, but including, as for today's issues, includes carbon. And we can also monitor forest change. We can detect change, and of course that would help carbon monitoring. So very quickly, Forecast, as I said, among other things, but Forecast is used here for carbon estimation and carbon monitoring. So for carbon estimation, what we do is we use LiDAR information, and we develop our own algorithms to create these maps and this information. We'll see later how it works. But we use LiDAR and algorithms to estimate the carbon stock in any forest. On the other hand, for carbon monitoring, we use mainly satellite imagery, usually Sentinel-2, but but the system is done in a way that we could use other satellite imageries. But well, Sentinel-2, and we develop artificial intelligence algorithms to work with these images and help estimate or detect changes and help carbon monitor. If we start with carbon estimation, if you go to Forecast and you have a license in Forecast, sorry that the images here are in Spanish, but it's easy to understand how it works. Once you go to LiDAR inventory, you can create a new project here. And once you create a project, you just have to upload a shape file, okay, the shape file and the corresponding other extensions of the file, okay. But so with this file, with this shape file, with some attributes such as stands or management units, we automatically have this map. In here, you can see the CO2, but you could go to volume, you could go to number of trees, you could go to decile area, whatever. And you have this information, this map on how it's the carbon per hectare, in this case, per stand. But this is just a way of showing it, like visualize it. The important thing is that once you have this done, you can go to, for each project you have, you can go to this kind of card, and then when you go to results, you can download all the cartography. And it's not only cartography, you can see a list of what you download once you have it done. And on one hand, you have some cartography, you see how it goes by pixels, it's just not stands. So now we have pixels, you can work with any geographic information system with it. And it's the way you can work with new data, cross data, and so on. But it's not only cartographic; it's also alphanumeric. And then we have the CSV information, data, spreadsheets, and so on. And one important thing that deals with transparency. Once you do it, you will see how there's some data, some files showing the diagnosis of the models that were used. So you will have the option of having the algorithms that were used, and you can see the statistical diagnosis of them. So that's a really good way to show how it really works and how the algorithms were used there. It's not just a black box when you don't know what's happening there. So it's in terms of transparency, I think that's very, very important. Okay, so with that, you could have for any area you want, if you have a LiDAR flight, LiDAR information, that's happening in all the 4 bioregions. So you can have this information of carbon or any other forest variable whenever you want, updated to the moment where you just ask for the you do the application in Forecast. Okay, so that would be carbon estimation, but we also have carbon monitoring. In order to do that, we use artificial intelligence procedures. Okay, so these procedures are focused on a couple of things. First of all, we develop cloud-free image mosaics. So we use Sentinel-2 imagery usually, and through artificial intelligence, we develop cloud-free mosaics. You can see a couple of examples here for Galicia in northwestern Spain for May and for October this year, but it's just an example. So that's the basis of what we're gonna use afterwards for the change detection. But not only it's cloud-free, we are using other artificial intelligence procedures to get to super resolution. As you may know, when using, for instance, Sentinel-2, Sentinel-2 has different spectral bands, and some of the bands have a special resolution of 60 meters, some others 20 meters, and some others 10 meters. So what we get with these super resolution procedures is to get everything to 10 meters. In fact, we already done it with 5 meters. It's quite more computer and time consuming, but it's done. I mean, it's doable. So that gives you a quite big jump in detail, because sometimes when we work, for instance, in Galicia, the areas we work with, the cadastral references are very, very small. So if you get smaller pixel, you will get more detailed or more precise information. Okay, so starting with that, once you have the cloud-free mosaics, you can do that. As you can see in the upper side, we have a couple of RGB images, one for May this year and the other one for June this year. As you can see, there's something happened here, and you can see some change in here. But this is just something you could just visualize. You could take a couple of images and see if, or a couple of mosaics, and see if there's some change. But of course, you don't have the information, so you should just go through images, just looking if there's something. So what we created is an alert system where we can detect all the changes, and we are not using just as you see here in yellow, okay, and orange. So we're not just using the monthly mosaics, or it can be monthly to bi-monthly, whatever the client wants. We go to each new image we have in Spain, for instance, in Galicia, that's an example in Galicia. Usually you have a new image every 6 days. So for instance, you can see here the May 24th compared to June the 3rd. So every time we have a new image, we download it, we process it, and we detect the changes related to compared to the last image or the last cloud-free mosaic. Okay, so once we have this at this day, then we have the next image here, and we can see how it develops, and that will help us detect all the changes. And just another final thing that is quite important. We have it like that, and it's just polygons, it's cartography. But the good point here is that we can go through WMS or API systems, and we can, if you work with governments or industries, they should have, or they usually have, their own forest management system or platform software. So what we do here is all our systems, all our alert system, they can just be sent through WMS or API to their system. They can cross with their information, and for instance, they can detect here, we send all the changes detected, and they can cross it with, for instance, the harvesting permits, so they can control if this change here, this harvesting we detected, is really, it has a permit or not, okay? And the same way that works for illegal harvesting, it can work for forest, for carbon monitoring, because once we have this alert system, we can just check with all the forests that have been used for carbon credits and control them, monitor them, and show how it was not forest before the planting, how it is forest now, and how in the future you can show the permanency. You can control the permanency of this forest for carbon credits. So you can assure that forest is not being cut. Okay, so that's a way we can do it, and that's one of the features of Forecast that it's clearly helping carbon monitoring. Okay, so I think I'm on time. Thanks a lot for your attention, and of course, I'll be happy to answer any question you have. Thank you.
ZertiCarbon, what it's all about, it's a forestation, digitalization, and monetization. And we are using the blockchain technology. And why we are doing this, actually, Inigo was saying extremely nicely that there is a lot of, the market is growing, there is a lot of players. But one of the key things for us since the beginning, it has been that we have to be transparent, because the transparency, I believe that we are building the trust. And then we have tried since beginning to build a reliable solution. And then our aim from the beginning has also been that as the forest owners, I'm located in Finland, forest owners only thing how they can have an income from their asset is actually selling the whether it's a pulpwood or then the timber. And none of them, as far as I know, they are horny to do this just to cutting the forests. But if they have a different kind of earning model, they will jump into this. So this has been the background. And who we are. So I'm located in Finland, and then Henri Syvänen is actually working also for the Risutech, who is manufacturing and selling the forest planting machines around the world. Then we have our, let's say, another segment or the professional guys for the blockchain technology, Mr. Paco Conde and Victor Seriniana in Spain, in Catalonia. And this is, let's say, that our team. Of course, we have other people also behind, but what we have actually done is that we have collected different professionals in order to make this all happen. So what are we doing in the forestation side? So different thinning models, fertilizing, planting processes, fast mixed forest, soil life under the roots, biodiversity. What means different thinning models? There is traditional thinning models in Finland, and then this means that there is, after the thinning, there is a certain number of trees per hectare or the volume. But what we are doing, so we are doing it with the small size machine, and we are leaving there more trees. Then fertilizing is something that we are not fertilizing just for fun. So we take the needle samples and then also ground samples in some cases. And if there is need for the fertilizing, we will do it. And why we are doing it, it's for the additionality, but on the other hand, also tackling the possible diseases, what we have been seeing now. We are doing planting process. It's a mechanized, we do it with the machine. We get each and every tree timestamp and GPS location, which is quite precise. We can plant each and every tree can be different, but I don't know whether this is, the main goal, but mixed forests we can do from the beginning. Of course, we are planting in the areas which has been the forest in the past. That's another story, but our main focus is in the wastelands. Then soil life under the roots. Why I'm mentioning this is because we are definitely using much smaller machinery compared to the, let's say, business as usual models. And the biodiversity is that I will explain you a little bit later on, but when we go to the tree level, when we are measuring, so we can easily make a tree map, and we can change from the monoculture to mixed forests. And I'm just telling you how it has been. So my father was teaching me when I was young that when you create the forest, you have to cut all the leaf trees and leave the spruces and pines there. But now it has been changing completely. So this is the things what we are taking into account. So that was the forestation. Then digitalization. So actually, I will not start to repeat, but Inigo was explaining you, we are also using drones, LiDAR, but also multispectra and then RGB. And then, of course, this means also a lot of field work. This was a good question, what was coming. So we are doing also test areas because I don't trust anything. So we have to know whether it's working or not. Our results are actually quite good. So my answer for this is that, is this the best way to do it? I don't know that, but at least it's precise and we are happy with it. So we make the 3D models. And then challenges definitely, if it's a forest is unmanaged, or each and every forest is from my point of view, each and every forest has their own soul. They are different. So then there is, let's say, we can easily see from the drones, we can see the dominance and co-dominance and so on. But then if you have a dominated trees, it's hardly to see. So that's the challenge. But then it's a question about how well the forest has been managed. Then our solution, the platform itself. So we are bringing then the flight data or the planting data to our platform. Each and every forest has their own let's say page, each and every forest block, and there you can find of course the tree mapping, what is the tree mix, then you have an ex ante curve for the carbon let's say storage, or you can see the growth, and that's the ex ante. This is the estimation, but then there is as we are creating also additionally the actions for each and every block in case the forest owner would like to sell the carbon. So then each and every forest block has the plan, and this means that the forest owner cannot just lay in the sofa, they have to also do the actions for the certain period. Then we have additionally the ex ante curve as well. But of course, this is an estimation, and then we have to measure it again. And of course, I'm happy to hear what Inigo was explaining. Now we are doing it with the drones. I hope in the future we can do it with the satellite data. So then we could get extremely precise information. Then each and every year you have the growth, and we are not selling future. We are selling the real growth, what we have there, and then each and every forest block has a plan, like I explained. There is a period for the action plan, so you cannot just make a 1 year period and then cut everything. It's definitely long term issue. Each and every forest block cannot be let's say used for the carbon capturing for the different reasons. So this is basically what we have. And then when we have the data and we have the growth, then we are actually turning it to the tokens. And the token is representing 1 ton, definitely 1 ton. We can split it to the kilos as well, but we are using 1 ton for the moment. And then if you do this, use this for the, let's say, compensation or the removal or let's say climate action, you cannot just use it like this. You have to burn the token, and once you burn the token, after this you can get the certificate. So why we are doing this? We are just avoiding that you cannot sell the same things twice. It's impossible. Like I explained, then we have the certificate coming out, whether you are individual or the corporation companies. The nice thing with the digital way, how we do it, is that you can then find the different solutions for the different businesses. I will show you something later on. Once you scan the QR code, then you can see from which forest, from which growing season, this the carbon storage that you are explaining that you are compensating and so on is coming from. Then this is just the one case study. It's a local transport company, and they have actually connected to our wallet to their trucks. So each and every truck, when it's consuming the diesel, it's connected to wallet, and they are actually then, what is the demand? They are burning the tokens, and they are from this way they are showing to their clients how they are doing. And then let's say that the sustainability, and they are trustable partner. And why I'm showing this, it's because you can do different solutions for different businesses easily. Are we only in Finland? No, we are not. We have made the pilots in Catalonia. We have been even planting in Manresa last year. No, actually in the beginning of this year. And then that's what we are doing. So we are doing the turnkey solution for the forest owner, and then scanning process, planting process, forest management, and then we have the platform where you can sell your products. And then the summary, I will not start to repeat myself, but we are connecting the forest owners and bringing another earning model for them, because once they have this, I believe that could be, and it is, we have already seen it, the important part to involve the forest owners. Even you are a small forest owner, you can join to our platform and do the actions. It's an optimal solution to environment. We are, like I explained, we are creating the new areas. It's true, it's based on the facts, and even the forest owner can see all the happenings what you have in your forest, and then when there is an action plan, you can see whether it makes sense to do such a things. No chance to sell twice and no double counting, and it's an economic solution to operate because you don't need the let's say middleman. Why I'm saying this is that, you know, I believe that if you are creating the carbon storage and do the actions, so you should benefit from that, not the middlemen. And this is a transparent on each step, and why I'm underlining this, it's because, like Inigo was saying before, there is so many players who are playing, I would not say that dirty game, but they are really hurting the carbon market. If we would like to unlock it, it has to be transparent and reliable solution that we leave. Because one thing that we always have to keep in mind, if we are cheating and we are bluffing, so we are actually cheating and bluffing ourselves. Then there is a questions and answers. There was already good questions coming from what can be done. Is this only for the forests? No, it's not, but the demand or how you can join to our platform, you have to be able to, or we have to be able to find the reliable data. We will not start to measure, for example, the peatlands if it's not reliable data that we can really measure it and then see that the let's say that the actions are true. But it's possible. How we do it? Are we creating the baseline? Yes, we do. I will later on. You can ask the questions how we do it and what does it mean. But yes, we do, because this is the base for everything. And are we selling the future, or is it our tokens existing from the existing growth? Our tokens are not for the future tokens. First, you have, you know, the CO, the carbon captured carbon, and then you can sell. And can the forest owners see transparency, the tonnage and growth? Yes. And do we use buffers and the security? Yes, we do. There is in each, you can never ever, if you have a 10 tons for sale, you can never ever sell the 10 tons. There is always a buffer that it goes so-called local basket. And then if there is a wildfire or some other things, there is, let's say that there is a security. Can we secure everything? I'm not lying. There is things happening in the world that we cannot really affect, but we do our best. Can you sell the same tonnage twice? It's impossible. And that's the, let's say that the benefit from the blockchain, it's impossible. And certificates we create. And then one important thing, I will not go through everything, but do we use the third-party audit to do our processes? Yes, we do. And then we have actually the certificate. Our process is certified. Okay, this is the ISO 1406442. This is not really directly for the, you know, the carbon process, but it's for the GHG, and then this is the best available. We are not using golden standard or Föra. We have our reasons for that. I will not start to explain you in detail why, but we believe that this is a good one, and they are anyway certifying our processes and the projects every year. And this is important for us in order to be transparent and reliable. And then once this presentation is shared, you can scan the QR codes and you see some actions what we are doing. There is a certain planting videos and other actions. So this is about the ZertiCarbon. Hope you got some answers and enjoyed the presentation. So thank you.